Okay, this is Algebra 2, Section 2A, two variable inequalities. Graphing. So when we graph these guys, inequalities, or two variable inequalities, or linear inequality, we're going to use less than, greater than, less than equal to, greater than equal to. When it's less than or greater than, we are going to have a dashed line. That means that it's up to the line but doesn't include the line, and it's called the boundary. And then if it's less than or equal to or greater than or equal to, our line is solid, meaning it goes to the line or the boundary, and it includes the line or the boundary. Then we have half planes. Half planes are the side that's shaded versus the side that's not shaded. So it can be either or. If it's the shaded side, the half plane would be shaded. If it's non-shaded, then the half side or half plane would be non-shaded. There's two sections, non-shaded and shaded. They say if you want to know if you want to find out whether your graph, rather which half plane to shade, you could put a test point, something that's easily put in there, and if it satisfies the condition of the graph, then you know which side to shade. For example, this one says y is greater than 3x minus 1. We would plug in a point, a test point, something real simple like 0, 0. You plug in 0, and then you have 0 times 3, which is 0, 0 minus 1, which is negative 1. And then since our y should be 0, 0 should be greater than negative 1. In this case, 0 is greater than negative 1, so since it's true, you're going to shade the side with the point. However, if it was the opposite and y was less than or equal to negative 3 and you plug in your 0, and we have 0 here as less than and equal to, then that's not the case, that's false. So you shade the side opposite of the particular line. Me personally, I can sort of eyeball this, and if it's greater than, I look at the y-axis, and it's going to go up because it's greater than. If it's less than, then I look at the y-axis, and it's going to go down because it's less than. That's usually how I eyeball these things. So if I was to graph this inequality, just eyeballing it, this is an eyeball. A right here, it's less a slope of 2 on the y-axis is 1. Right here, it's solid. It's a solid line, and it says y is greater than. So again, I look at the I looked at since it's greater than, it's going to sort of be shaded up top because it's greater than in the y-axis. So I look at the y-axis to determine it. But you can also put a test point in here. In this case, probably 0, 2. That would be a test point. 0, 2. And if I plug it in, 2 should be greater than or equal to negative 2 times 0 plus 1. So 2 is greater than or equal to 1. This works. So then I'm correct in shading that. You can also plug it in to your graphing device and see if that also works of your choice. So that was y is greater than equal to, what was it, negative 2x plus 1. There you go. And the same thing applies. So that's my confirmation. Yay. Here I have y is less than negative 2x plus 1, so it's going to be a dashed line. La 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 la. And it's going to be shaded down. La, 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 because it's less than on the y-axis. I base everything off the y-axis. I think it's a pretty good barometer as to how to do these things. So let's change that to less than, and we get a dashed line through that same poisonous, going downward on that y-axis. Okay. We can use these things to solve problems, graphing sets of graphing on combination lines here. So it says, suppose you decide not to spend more than $30 for tickets. What are the possible combinations of large and small rides? So it's 30 tickets. You can buy 60 tickets with $15. And I spent $30 worth of tickets. How much? So $30 worth of tickets. It says that if I can buy $60 with 15, then I can buy for 30 bucks. I should be able to buy 120 tickets. So we have small rides is 3x, big rides is 5y. So this is going to be 3x plus 5y equals 120 total tickets. So I can find my axes. So what what is my y when x is 0? So if x is 0, then it's going to be 5 into 120. Which is 24. So I can 24, and if my y is 0, then that would be 40. So that would be my 2 points. So if I was to graph this guy, it would be 3x. It would be large rides over here, small rides over here. So this would be large, this would be small, this would be, I'm eyeballing it, this would be 0, 24. And this would be 40, 0. And I would connect the dots here. Anything shaded in here is combination of tickets that would fit this scenario based off of what I have. I only can have up to 40 small ride tickets, and I can only have up to 24 big ride tickets. And these are combinations of small and big rides, and shaded underneath, because I can't have more, right? I can't have more than 24. I can't have more than 40. So I have with the shade underneath, and those would be my combinations of tickets. And that would be less than or equal to, because I can get up to the line. So when I put this on my decimal, it'll be 3x plus 5y is less than and equal to 120. Well, that didn't work. They want this in y form. That's fine, we can do that. Oh, I know why. Because it's only my border is only up to 10. So I'm going to say 12 for right now, just because to fit my border. Again, I can't go past a certain point, and if I was to make this bigger, it would stop at whatever the 0 and the y would be. So it works. Okay. We can also graph absolute values using an inequality. Um, Again, I based everything off the y-axis. So if they gave me something like this, y equals -4 is greater than or equal to 2 absolute value x minus 1. I'm adding 4 to both sides, so that's y is greater than or equal to 2 absolute x minus 1 plus 4. So I know my vertex is at 1 and 4, and it would be upward facing, and it would be stretched by 2. So if I was to do this, it would be like sort of like this. This would be 1 and 4. Since it's greater than, my y values have to be greater, so I would be shaded on the inside, like so. Everything on the outside would be not shaded. So let's see if I can graph that. Y absolute value of 2x minus 1 plus 4. 2 absolute value x minus 1 plus 4. And there you go. Since it's greater in the y, I base everything off the y-axis when I eyeball these things. It's going to be shaded on the inside. Now, if this was less than, it would be everything shaded on that lower than that y value on the outside, in case you were wondering. Writing an inequality based off of the graph. Again, you can eyeball it using the vertex, where it is across the y. So if I look at this, I'm looking at where my vertex is. My vertex is at 1, 2, it's actually 2, 4. 2, 4, and 2. So my vertex, my h, actually let's do a vertex. My vertex would be -4 and 2. That means my h is -4. My k is +2. So when I write this, it would be, I would need the slope. So I would look on the right, branching right, to find the slope. So here, there's not really a good line, is there? I was going to go down. I can go right here. I'm going to say that's a 1. The y-axis hits at a 1 as well. We would have to find that slope. Oh, they're asking what inequality does it represent. Oh, okay. Well, the inequality that it represents is greater than, because it's above the y-axis. Here's the equation of the line right there. Okay, cool. That line represents greater than. I guess. I thought they wanted me actually to graph it, or set the equation, so I misinterpreted the question. Okay, so that is that section. I hope you have a great rest of your day.